circuits. So the objective of our lesson is describe how an exterior lighting system works, written in terms of the bulb chart, discuss the operation of brake lights and turn signals, inspect, replace, and aim headlights and bulbs, discuss troubleshooting procedure for lighting signaling circuits. This chapter will help you prepare for ASE, Electrical Electronic System, certification test, content area, lighting system diagnosis and repair. So our first discussion is exterior lighting, headlight switch control. Exterior lighting is controlled with the headlight switch, which is connected directly to the battery on most vehicles. Computer controlled lights, step step 1 to 5. So bulb numbers and brake lights. First one is trade number, candle power, bulb numbers, suffix, testing bulbs, normal resistance, 0 ohms, all electronically open, brake lights in operation. So first is what is trade number? Trade number refers to standardized identification system for bulbs used in vehicles, helps in ensuring compatibility and interchangeability across different brands and models. Candle power, this measures the intensity of the light emitted by bulb. It's essentially a unit of luminous intensity indicating how bright the bulb is. Bulb number suffixes, these are additional letters or numbers added to bulb number to denote specific characteristics such as voltage, base types, or design variation. The testing bulbs. When testing bulbs, you might encounter different readings. Normal resistance, this refers to resistance of the bulb under normal operation conditions. 0 ohms indicates a complete circuits with no resistance. This might be reading when the bulb is intact and functionally properly. OLR means electronically open, indicates an open circuits, meaning there's a break in the circuits and the current cannot flow through the bulb. This could be due to a blown filament or other internal issues. The brake light operation. Brake lights are essentially safety features in vehicle. They illuminate when the driver applies the brakes, indicating to other drivers that the vehicle is slowing down or stopping. They typically use bulbs with higher candle power compared to regular lights to ensure they're easily visible, especially in daylight or adverse weather conditions. So, dual filament or dual conduct bulbs contain both a low density and filament or taillights or parking lights and a high intensity filament for brake lights and turning signals. Bulbs comes in a variety of shapes, sizes, and bulbs shown are the traded numbers. So these are the bulb chart. Bulb chart sorted by typical application. Checks the owner's manual service information or the bulb manufacturer application chart for the exact bulb use. So you're going to please find the exact bulb in order uh, to find the right bulb in a specific bulb that you use in your car. So these are the examples.
If you're out there looking for new bulbs for your project, it's probably kind of confusing if this is your first time. A lot of bulbs look the same, but they have different numbers. And a lot of bulbs have similar sounding names, but they look totally different. So in this video, I'm going to try and do away with some of the confusion and help you understand what you're looking at or what you have now and how to get the right thing for your project. If you want to figure out what you have now so you can get the right product for an upgrade, you have a few different ways of doing it. The easiest thing is take your vehicle apart, pull out the bulb, and on the bottom or somewhere on the bulb is going to be the name of the bulb or the part number. This one, for example, says Sylvania 9006 HB4U. Don't worry about the U. You can either get a 9006 or an HB4. Both parts will fit the same light bulb. And that's because auto manufacturers use many different names for the same or similar bulbs based on the application. You're going to get a brighter bulb or a less bright bulb based on that part number. Now, aftermarket bulb manufacturers just take the standard size and they say this 9006 fits 9006, HB4, 9012, etc. So the first thing you have to do is figure out what you have and then figure out which bulb is compatible with yours. So for example, we have a 9006 and a 9012. They have very similar looking bulbs up top. The connectors are identical. The O-ring diameter is the same, so they fit all the different applications, but as you can see, the three plastic tabs are slightly different. So you're gonna find somebody who makes a bulb that fits both of these, or you're gonna find somebody who makes a 9006 and a 9012. So you just have to do your research. Find out what you have, and then find out what's compatible with it. Another example of the same thing is with 9005 bulbs. Now these are commonly used in high beams and fog lights. So if you have a 9005 bulb, your LED counterpart is going to look like this. The interesting thing though is a 9145 or an H10 for your fog lights is going to look like this. It's the exact same bulb, just a slightly lower wattage, and it has a cap on top. And then a brighter bulb, the 9011 or the HIR1, is again pretty much the same bulb, but it's a little bit brighter. Now that's confusing. Why would you use a 9005 to replace an HIR1? Well, the reason is because these manufacturers take the same plugs, the same mounting collars, the same O-rings, and they just make the inside part of the glass where the filament is a little bit brighter. Now, there might be a dozen different variants of this bulb in the halogen world, but with LED, you're going to get one bulb that fits them all. That's where a compatibility check is really important. Step 1, figure out what bulbs you have. Step 2, find an LED or HID bulb that's compatible with your part number. This one 9005 might fit multiple 9005 type light bulbs. Another example of similar bulbs with totally different names that an aftermarket bulb fits both is H8, H9, and H11. If you have any of these light bulbs, they fit your fog light, low beam, and high beam. An H11 LED bulb or HID bulb is going to work. We're talking about these ones in front of me. You have the H11, which is the more common style with the little painted cap, and an H9 without a painted cap. But everything else about them physically on the outside is the same. They have the same type of filament, they have the same mounting points, they have the same O-rings, and they have the same connectors. So other than the brightness, they're pretty much interchangeable. So instead of these LED bulb manufacturers making an H8, H9, and H11, they make one bulb that fits them all. You can see here's the H11 version with the same O-ring, the same mounting tabs. The LED chip is in the same place as your filament, and the wire harness is the same. So if you have an H8 light bulb in your fog lights, but all you can find is an H11, that's the right bulb. Now you're also going to see interchangeability on something like this. This is an 880. Now the funny thing about the 880 is this bulb also has about 10 other variants. 881, 890, 891, and the list goes on. 800, 802. The LED bulb looks like this. It's got the same O-ring, mounting collar, and the connector is the same. Now this 880 bulb or 800 bulb is going to fit all of the different variants of this halogen bulb. The other interesting thing though is the connector is the same on an H11. The 880 bulb and the H11 can plug into each other, and they look similar. They have 3 mounting tabs, but they're totally different bulbs. The 880 and the H11 are not interchangeable. So once you've figured out what bulb part number you need, the next step is to find an LED bulb that's compatible with it. One LED bulb may be compatible with a dozen different halogen bulb part numbers. Another really confusing one is H1 and H3. These bulbs are normally used in fog light applications, but they're also really popular in aftermarket headlights. The H3 on this side with the cord coming out is totally different looking than the H1 that doesn't have a wire. Now in LED and HID world, they are not interchangeable at all. Even though the names and the look are kind of similar, as you can see, they're totally different. For an LED or HID system, to replace these in a fog light application, for example, you're going to want an H3 LED bulb for an H3 halogen and an H1 LED bulb for an H1 halogen. Same goes for H7. You can see this H7 doesn't look anything like an H3. They're not even close. H1, H3, H4, H7, H8, 9, 10, H11. They're all similar sounding names, but they're totally different light bulbs. The H7 has 2-prong connector on the bottom that you would replace with an LED system that has this kind of connector. And on the top, you need the mounting collar to match. You can see the halogen bulb has a round mounting collar with a flat tab that comes out the top, and so does the LED bulb. So just because they're similar names doesn't mean that they're automatically interchangeable. Here you have an H1 bulb. Here you have H3. Here you have H7. And here you have H11. Even though they're similar sounding names, they aren't even close to the right thing. In order to find the right bulbs, there's a few different ways to do it. The first option is take the bulb out and look at the back. Somewhere on the bulb, you're going to have the name printed on it. The second option is to look at your user manual. It should tell you what bulb part number you have. The third option is you can go to websites that specialize in automotive bulb lookups, and it'll tell you what your bulb part number is. Step 2 is call your favorite lighting supplier and say, hey guys, I have an H11 or I have an H7, H1. What do I need in order to do the upgrade? And they'll help you from there.
So, bulbs that have same trade number have the same operating voltage and weightage. The NA means that the bulb uses a natural amber glass ampule with clear turn signal lenses. The close-up of a 2057 dual filament double contact bulb that failed. Notice that the top filament broke from its mounting and mounted into the lower filament. This bulb caused the dash light to come whenever the brakes are applied. Corrosion caused the two terminals of this dual plant to be electrically connected. Often the best diagnosis is through visual inspection. This bulb was found to be filled with water, which caused weird problems. This single filament bulb is being tested with digital multimeter set to read resistance in ohms. The readings of 1 ohm is the resistance of the bulb when cold. As soon as current flows through the filament, the resistance increases about 10 times. It is the initial surge of current flowing through the filament when the bulb is cold that causes many bulbs to fail in cold weather as a result of the reduced resistance. As the temperature increases, the resistance increases. This is the typical brake light and tailing circuit showing the brake switch and all of the related circuit components. A replacement LED tail light bulb is constructed of many small individual light emitting diodes. Turn signal. The operation on filament stop turn bulbs, two filament stop turn bulbs, flasher units, DOT flasher, bimental flasher, and hybrid flashers. So, the operation of turn signal is also known as a blinkers or indicators. Are lights in a vehicle that signal the driver's intention to turn or change lanes. When activated, they flash on the front and rear of the vehicle, indicating the direction in which the vehicle intends to turn. The one filament stop turn bulbs. This bulb serves a dual purpose as both stop, brake lights, or turn signals. They have single filament that fills up for both functions. When the brakes are applied to the bulb, emits a steady light, and when the turn signals are activated, it blinks. The two filament stop turn bulbs. These bulbs are designed specifically for vehicle where the stop brake light and turn signal function are separated. They have two filament, one for the brake light and another for the turn signal. This allows for independent operation of the two functions. The flasher units. Flasher units are also called flasher relays or blinker relays are electronic components that control the flashing rate of the turn signals. They regulate and timing the duration of the flashing sequence, ensuring the compliance and safety standard is visible to other drivers. The DOT flashers. These are flasher units that meet the requirements set by Department of Transportation in terms of performance, reliability, and safety standards. Bimetal flasher. Bimetal flasher are the types of flasher unit that operates using a bimetallic strip. When current flows through the strip, it heats up and causes the strip to bend, breaking the circuit. As it cools down, the strip returns to its original position, completing the circuits again. This cycle repeats, resulting to flashing effects. The typical turn signal switch includes various springs and cams to control the switch and to cause the switch to cancel after a turn has been completed. In the stop lamps, turn signals share a common bulb, filament, stoplight. Current flows through the return signal switch. When the right turn is signaled, the turn signal which contacts send flasher current to the right hand filament and brake switch current to the left hand filament. Two styles of two-prong flasher units. Electronic flasher replacement units, hazard warning flasher, combination turn signal and hazard warning flasher. A hazard warning flasher uses a parallel resistor across the contacts to provide contacts flashing rate regardless of the number of bulbs used in the current. The side marker lights goes out whenever there are voltage at both points X and Y. This opposing voltage stop current flow through the side marker light. The the left turn light and left park light are actually the same bulb, usually 25 level, and are shown separately to help explain how the side marker lights work on a beacon.
This is one of the most basic flasher designs available. It takes what would have normally been a steady on voltage and turns it into an on-off signal. What's interesting is that it uses nothing that could even remotely be considered a computer inside of this in order to make that signal. Because the flashing rate of this isn't digitally controlled, it can actually speed up and slow down based on a number of factors. I've already opened this up, so let's take a look inside. On this particular model, electricity has two different paths that it can take to get from one pin to the other, and sometimes one of those paths isn't available. The path that is always available is a tiny wire that's wrapped around a strip of metal. That tiny wire can't handle the amount of current that's passing through it, so it starts to heat up. More importantly, it heats up the strip that it's wrapped around. That strip of metal is made out of a different material than the metal it's attached to, and it will expand when heated at a different rate. Because both of these pieces of metal are attached at 2 points, when one expands, it's going to want to bend the other. Eventually that strip expands to the point where the secondary piece of metal gets pushed into another electrical contact and allows electricity to flow through that instead of that wire. Because electricity is now able to flow through an easier path, the first path can take a break and it starts to cool down. Eventually it cools down to the point where the metal will actually snap back out of place, and that secondary path for electricity to flow down is no longer available, and everything starts heading through that small wire again. This process will continue on until the user turns off the turn signal. However, this will actually flash at different rates depending on how many bulbs you have and some other factors. While this bulb isn't much of a resistor, it is a resistor. It resists the flow of electricity. It won't stop electricity completely, but it will slow it down in the form of reducing the amperage. These two components are going to be in series, which means electricity flows through one first and then the other. However, turn signals typically aren't just one bulb, and you don't have one of these for every single bulb that you have. Imagine there's people trying to get out of a building and there's only one door. That door is this light bulb, and the current is how many people can get through that door. Things in series would be like there's one door and then there's another door and you have to go through one first and then the other. However, parallel doors are like one door is over here and one's over here, and people can head through both of them at the same time. When people can go through both of them at the same time, the amount of amperage, as in how many people are getting out of the building all at once, is higher. Your turn signal bulbs, as in the front one, the rear one possibly in the mirror, and any of your marker lamps that turn on and on when a turn signal is activated, those are all in parallel. The more light bulbs you add to the circuit in this way, the more amperage you get overall when the circuit converges. In order for a flasher unit to handle all those bulbs, then it has to be on that point where the circuit converges and it's handling all of that amperage. With that extra amperage, you get more heat in that tiny wire, which means this heats up faster and turns on and off faster. One of the drawbacks to this particular flasher is that it has to warm up first before you get your first light out of your turn signal bulbs. There are some thermal flashers out there that would also use a bimetallic strip like this, that instead of heating it up to make it make contact, heating it up pulls the contact away. However, both designs tend to not play very well with LED replacement bulbs. Modern flasher units are more digitally controlled and sometimes have artificial sound in them to replicate the original sound of a thermal flasher. Sometimes you don't even get a replaceable unit like this anymore, and it's just a system that's built into an ECU or similar computer. So when you upgrade your turn signal bulbs to LEDs, sometimes it's necessary to get a flasher unit that's compatible with LEDs, or if you have one of those ECU setups that is controlling the signal, you sometimes have to trick it into thinking that you have normal bulbs when you have your LEDs installed. This is a resistor unit that will be installed parallel to the bulb.
Headlights. Headlights switches automatically. Automatic headlights, sealed beam, headlights, halogen, sealed beam and headlights, composite headlights. Typical headlight circuit diagram. Note that the headlight switch is represented by a dotted outline indicating that other circuits such as dash lights also operate from the switch. Typical for headlight system using sealed beam headlights. A typical composite headlamp assembly, the lens housing and bulb socket are usually included as completely assembled. Handle a halogen bulb replaced to prevent skin's oil from getting on the glass. High intensity discharge headlights, the parts in operation, the startup and stroke state, run-up state, steady state, bisecnon headlights, failure symptoms, and diagnosis and service. The high intensity discharge of HID headlights are a type of automotive lighting system that produce light by passing an electrical current through second gas within a sealed quartz capsule. Understanding the parts operation and common issues associated with HID headlights can help diagnose and service them effectively. The parts in operation. Secnon bulb. Filled with secnon bulb, the bulb produces a bright white light when electrical arc is created within it. Ballast. The ballast regulate the voltage and current supply to the bulb, ensuring the stable light output. Igniter. Initiate the electrical arc within the bulb. Reflects and focuses on the light emitted from the bulb onto the road. Reflector. The startup and or strike state. When the headlights are turned on, the ballast initially supplies a high voltage to create an electric arc within the second bulb. This phase is characterized by a brief intense flash of light as the arc is established. The run-up state. The ballast stabilize the electrical current flowing through the bulb, allowing it to reach its full brightness. During the phase, the headlights gradually reach their optimal illumination level. The steady state. The headlights operate at a consistent brightness level where the vehicle is in use. Bihexenon headlights. Bihexenon headlights incorporate a single second bulb that can produce both low and high beams by mechanically adjust the position of the shield within the bulb. This design allows compact headlight assembly while providing high and low view functionality. The failure system symptoms: flickering, intermitting flickering of the headlights may indicate a problem with the ballast or wiring. Dim or uneven lighting, reduce of brightness, or uneven lighting outputs may suggest a failing bulb or ballast. Failure to ignite. If the headlights fail to turn or take a long time to reach full brightness, there could be an issue with the bulb, ballast, or igniter. Diagnosis and services. Visual inspection. Check for any visually visible damage to the bulb, ballast, or wire. Electrical testing. Use a multimeter to test the voltage and continuity of The electrical components. Replacement. Replace any faulty components such as bulb, ballast, or igniter with the compatible parts. Alignment. Ensure the proper alignment of the headlights. Optimize light output to prevent glare from other drivers. Professional service. If unsure or if the issue persists, after the basic troubleshooting, consult a professional automotive technician for diagnosis and repair. So the igniter contains the ballast and transformer needed to provide a high voltage pulse to the arc tube bulb. HID of Technon headlights emit a whiter light than halogen headlights and usually look blue compared to halogen bulbs. The lighting, LED headlights, headlight aiming, adaptive front lighting system, parts and operation diagnosis services. So LED headlights usually require multiple units to provide the needed light as seen in this Lexus LS 600H. So these are the typical headlight aiming diagram as found in the service information. Many composite headlights have a built-in bubble level to make aiming easy and accurate. Adaptive front lighting system rotate and low beam headlight in the direction of the level. A typical adaptive front lighting system uses two motors, one for the up and down movement and other for rotating and low beam headlight to the left and right. Typical dash mounted switch that allows the driver to disable the front lighting system.
In this video, I am going to teach you easy steps to adjust your headlights at home. First, remove any excess weight from the trunk of the car. Make adjustments to get your vehicle to its average weight and height. Park your car on level ground, facing a perfectly vertical wall. Level the shocks by pushing the corners of the car down. Just go to each corner of the vehicle and firmly push down on the body to make your vehicle pop up and down a few inches. Alternatively, you can measure the distance to the ground from both headlights to ensure that the suspension itself is level. Turn the headlights on and mark the centers on the wall. Locate the brightest point of light on the wall for each bulb. Use masking or painter's tape to put 2+ signs on the wall. Place a spirit level between the two marked center lines to see if they are even. If they are not even, use a tape measure to measure how far up the wall the lower mark is and lower the other center line marker to the same height. Back your car exactly 25 feet, 7.6 meters from the wall. Some manufacturers recommend different distances for proper adjustment, although 25 feet is the most common distance. If the brightest points aren't the center of each plus, you need to adjust your lights horizontally. If your lights are too high, they can blind other drivers. If they're too low, you won't be able to see pedestrians and other cars in time to prevent accidents. Locate the adjusting screws on the housing for each light. Every model works basically the same way, one screw is for up and down adjustments and the other screw is for left or right. You use a screwdriver to manually adjust the angle of the bulb. Block one headlight so you can focus on adjusting the other. Turn the upper screw or bolt to adjust the vertical field. Clockwise usually raises the lights, while counterclockwise turns should lower them. Adjust the other set of screws or bolts to make horizontal adjustments. Use the same screwdriver to make adjustments to the second screw, if necessary. Make any additional adjustments by repeating the process again until your lights are correct. Do this at night. You aren't going to be able to see whether your lights are correct or not during the day. I hope you like our video. If you do, hit like, subscribe and share.
Lighting, daytime running lights, the purpose and function, dimmer switches, courtesy lights, illuminated entry. Fiber optics and parts and operation. So the typical daytime running light or DRL circuit follow the arrows from the DRL module through both headlights. Notice that the left and right headlights are connected in series. resulting in increased resistance, less current flow, and dimmer than the normal light. When the normal lights are turned on, both headlights receive full battery voltage and left headlights grounding to the DRL module. Most vehicles use positive switch for high and low beam headlights. Notice that, notice that the both filaments share the same ground connection. Some vehicles use negative switch and place the dimmer switch between filaments and the ground. A typical courtesy light door jump switch. Newer vehicle use their switch as an input to the vehicle computer and the computer turns the interior lights on or off. By placing the lights under the control of the computer, the vehicle engineer have the opportunity to delay the lights after the door is closed and to shut them off after the period time to avoid draining the battery. The automatic dimming mirror compares the amount of light towards the front and the vehicle of the rear of the vehicle and applies the voltage to cause the gel to darken the mirror. Feedback. So the lighting system diagnosis. Step 1, verifying the customer concern. Step 2, perform a visual inspection. Step 3, connect the factory and instance. Scan the tool and bidirectional control of the computer module. Step 4, follow the diagnostic procedure as found in the service information to determine the root cause of the problem. So if the problem is one headlight dim, the possible cause or solution for ground connection on body corrected connectors. The problem interior lights inoperative. Possible cause and solution is burnout bulbs open on the power side circuit with low fuse. So if the problem is one headlight out or low or high beam, the possible cause burnout headlight filament or open circuit. If the problem is interior lights on all time, possible cause certain door jam switch, shorted control switch. The brake lights, the problem is on the brake lights inoperative. The possible cause defective brake switch, defective turn signals, burnout brake lights, bulb, open circuit or poor ground connection. The problem is hazard warning lights inoperative, defective hazard flasher unit, open and hazard circuit, blown fuse, defective hazard switch. The problem is hazard warning lights blinking too rapidly. The possible cause or problem is incorrect flasher unit, shorted wiring to the front or rear lights, 3 or incorrect bulb numbers. The problem also about all the headlights is inoperative. The possible cause or solutions are burnout filaments in all headlights. Solution, you can check for excessive charging system voltage. If the problem is low turn signal operation, the possible problem is defective flasher unit or high resistance in socket or ground wire connection or incorrect bulb numbers. So if the turn signal operating on one side only, the possible problem or cause burnout bulb or affected side, poor ground connection or defective socket on affected side, incorrect bulb number or affected side, defective turn signal switch.